Hey guys, we're going to finish off this chapter with bearings. Okay, and so with bearings, it's really important that you know your orientation. And I guess these days we just follow whatever the GPS or Google Maps or Apple Maps say, and we lose a bit of orientation relative to where we've come from, where we're going, and all that kind of stuff. If I asked you at your own homes, where is north, south, west, or east? Would you be able to pick that out straight away? Or would you have to ask mom and dad or whoever else that's in your home that be able to answer for you? So let's look at this. We've got north, east, south, and west. And what I want you to understand, true bearings, okay, uh, I guess, is all relative to north. Okay, and so here we have true north, and when we're going from, so when north, we're looking at 0 degrees. Okay, east is at 90 degrees, south is at 180 degrees. We have 270 degrees, and I guess the revolution goes back to 360. Okay. And so anything in this quadrant going from 0 to 90, we're looking at an acute angle. Okay. Anything that goes from 90 to 180, we're looking at an obtuse angle. And then if we're going around clockwise up to 270, we're looking at reflex angle. And then if we're going back to north, I guess we're looking at reflex, and all the way around to the top, we're looking at a revolution. Okay. But this is just to kind of give you an idea and reference, because you know how to get to school from your home, and therefore you should know how to get back home from school, right? But your reference and your bearings is going to be different because you are from a different position. Okay, so what I mean by that is, let's say, for instance, you are, this is home and this is school. Okay, so the bearing, let's just use a different color here. Your bearing here is based on true north, which is that angle there. And let's just say that it's 30 degrees. Cool. So your home facing north, the school is at a 30-degree angle. So, but if we were to be at school, okay, and again, all relative to north, and we want to know which direction or what's the bearing or the orientation of your home from school, we're starting at north, going all the way around back to the direction that you would go to school. Okay, and so that is 180 degrees plus the extra that is in here. Okay, so now I want you to really think about this. We have alternate angles here. Okay, and so this part would also be 30. So 180 plus 30 degrees is 210. So your bearing from school to home is 210 degrees, but going from home to school is 30 degrees north. Okay, so hopefully that helps you just in its simplest form how the bearings actually work and relative to which direction you're facing and going. Okay, so I've got a couple of examples that I'd like to run through with you guys, and we're going to start off with this one here. A boat travels a distance of 5 kilometers from P to Q in a direction of 35 degrees. Now, 35 degrees true north is an acute angle. So we can comfortably say that it's going that direction for 5 kilometers from P to Q. Okay. Now the question is asking how far east of P is Q. So we're wanting to know this horizontal distance. Okay. So let's make a triangle out of this, a right angle triangle, and to work out x, well, we know that this angle here is 35 degrees, and it's really important that you don't put 35 in this corner. It's just a common mistake that people have and do in the past. So if this is 35, then that makes this angle, I guess, the complementary of, whatever adds up to 90 degrees. So we're looking at, say, 55 degrees. Okay, so 55 plus 35 is your 90. We can then use our trigonometry to work out x, which is your adjacent. So we've got adjacent, and 5 is our hypotenuse. So therefore, we're going to use cosine. Cosine of 55 is equal to our adjacent over our hypotenuse. So x is going to equal cosine of 55 times 5. And see if I still have my calculator here. Okay, so cosine of 55, close brackets, times 5 is equal to, and let's just get this into decimals, so x is equal to 2.9. Let's just make it to 2.9. Okay, so there's our distance of P to Q, like how far east is P. All right, so now we're moving on to part B. How far north is P, of P is Q. So now we're looking at that distance there. Okay, so what I'll do, I'll put that in a different color. So we're wanting to work out that distance here. Okay. And in this case, we're going to use the same angle, 55. But now y is the opposite, no longer the adjacent. So we're going to use the opposite and the hypotenuse. We need sine. So sine of 55 is equal to the opposite over the hypotenuse, which is 5. So y is equal to sine of 55 times 5. Okay, so bring this back up. We'll go sine of 55 times 5 is equal to 4.1. Okay, so y is equal to 4.1. All right, and then lastly, what is the true bearing of P from Q? Okay, so if P to Q is 35 degrees, we're wanting to know what the bearing is of that angle there. Okay, bearing of P from Q. So going from here to here, we're looking at 180 plus our 35 because this is alternate to that, and that makes it 215 degrees. Okay, cool. Let's have a look at the other example. We have now a boy walks 2 kilometers on a true bearing of 90 degrees. So 90 degrees is towards the east. So east for 2 kilometers. And then walks another 3 kilometers on a true bearing of 130. So 130 is an obtuse angle. We're looking at going down that direction. Okay, and we're just doing it approximately. So 3 kilometers that direction. And so let's put our references so you kind of know what we're dealing with. orange. So that's the first 90 degrees. And then the second part is looking at that which is 130 degrees. Okay, so there's what we have so far. How far east of the starting point is the boy at the completion of his walk? So we're wanting to work out east. So from this distance all the way to this distance, which is, aligned to this final destination, we know that this portion here is 2 kilometers. We don't know what this portion here, but we can work it out through trigonometry. Okay, so to work out x, we've got 3 being the hypotenuse, and we can work out that this angle here is going to be 130 minus 90. So it must be 40 degrees. Okay. X is your adjacent and 3 is your hypotenuse. So let's work this out. We've got, we need to use cosine. So cosine of 40 is equal to our adjacent x over our hypotenuse, which is 3. So x is then cosine of 40 times 3, and our distance of x is therefore cosine of 40, close brackets, times 3 is 2.3. Okay, so 2.3 kilometers is going to be that distance. Now, if this is then 2.3, therefore the answer is going to be 2.3 plus the 2 original going across, 4.3 kilometers. How far south of the starting point is the boy at the completion of his walk? So now we're looking at going from, going to be running out of colors here, from this point here from this point to this point. Okay, so we're wanting to work out that distance. So we've got our angle, which is 40 degrees. We're wanting to work out this one, which is the opposite now. And we'll still use 3 as our hypotenuse, so we just need sine. So sine of 40 degrees is equal to the opposite, which is y, over our hypotenuse, which is 3. Okay, y is then equal to sine of 40 times 3, and we'll put that in our calculator. So sine of 40, close brackets, times 3 is equal to 1.9. Okay, so 1.9, y is equal to 1.9 kilometers. That's going to be the answer to part B. Okay, lastly, to return directly to his starting point, how far must the boy walk and on what bearing? So let's redraw this. So here's his end point, and we've got this. We can generate this triangle. Okay, we know this triangle is 4.3 kilometers. Sorry, this side of the triangle is 4.3 kilometers. We know that this side is 1.9 kilometers. And we are wanting to know what the bearing is. And the bearing going from here back to here, okay, which requires us to use this bearing. That's the bearing that we want, okay. So what's the best way to do it? Is to work out what this angle is and take it away from 360. And we've got two sides, and this we can make as the adjacent, and we can make this one as the opposite. So we will need the tan function, but theta is the inverse of tan, and our opposite is over our adjacent. Okay, so theta. So we're going to go into our calculator and work out theta. So we'll put in inverse of tan, and we'll have 4.3 divided by, let's go back into calculator, here we go. So inverse of tan, and 4.3 divided by 1.9, close brackets, we get 66, and we'll round off to the nearest degree. So we got 66 degrees is what theta is, but obviously we want to take that away from 360, so 360 take away 66 is going to give us 294. So the bearing, bearing is 294 degrees true north. Okay. Now the question is, how far must the person walk, or the boy walk? And we can then work on what color should I use this time. I'll use this one. So we need to work out what the hypotenuse is, and we can work out through Pythagoras. So 1.9 squared plus 4.3 squared is equal to h squared. Let's get a calculator. 1.9 is 3.61, and 4.3 is 18.49. And so we got 22.1 is h squared. So that means when we square root both sides, the square root of 22.1 is 4.7. So the distance that the boy needs to walk at a bearing of 294 degrees true is 4.7 kilometers back to where he started. Hope that works and helps for you. Hope it makes sense and helps you guys understand bearings. Can be a little bit tricky, but let me know if you got any questions. Otherwise, see you in the next one.